Welcome to lesson 11.3 for honors geometry. So today we're going to go over perimeter and area of similar figures. And we've touched about on perimeter for similar figures before, but today we're going to learn specifically how perimeter and area are related to each other with regards to similar figures. So we're going to only learn one new theorem in this lesson, and this is about how those ratios correspond to each other. So theorem 11.7 states that if two polygons are similar with lengths of corresponding sides in ratio of A to B, then the ratio of their areas is going to be A squared to B squared. Okay, so we have two similar polygons in here. Polygon 1 is similar to polygon 2. And specifically, we're going to know that they're similar in a ratio of A to B. So that means that their side lengths are going to be similar in that regards. So when we write that ratio, we know that this ratio can correspond to the side lengths and it can also correspond to the perimeter. But when we're talking about area, we're going to be talking about square units. So the way that these two polygons are similar with regards to area is going to be A squared over B squared. And that's how we can figure out their ratios. So now that we have this equation and this ratio or proportion, let's go ahead and move on to a couple of examples that use this. So we're going to use this example to find using the area to find the perimeter. So we need to find the perimeter of a rectangle whose area is 675 square inches and is similar to another rectangle that is 24 inches wide and 18 inches long. So the first thing that we need to do is find the area of our second rectangle. And we're going to label these figure number 1 and figure number 2. So we need to find this figure's area. So remember, our area is going to equal our base times our height, so 24 inches times 18 inches. And when we multiply that out on our calculator, we end up with an area of 432 square inches. Okay, so now that we have this area, we can find how they are in proportion to each other since we know that they're similar figures. So their proportion ratio is going to be A squared over B squared, or in this case we're going to do figure 2 squared over figure 1 squared. So that equals 432 inches squared over 675 inches squared. So now, when you simplify these, you can reduce these down to where we can find their squares. We end up finding out that their squares are going to be 12, or the square root I should say, will be 12 square root of 3 squared equals 432 over 15 square root of 3 squared. So we've got our A squared over B squared. And we know from our previous theorem that the perimeter is going to be similar in a proportion of A over B. So that's going to equal 12 square root of 3 over 15 square root of 3. And this can simplify to 4/5. So this is how their perimeters are going to be similar. So now let's go ahead and find the perimeter of figure 2. We can do that since we have its length and its width. So the perimeter of figure number 2 is going to equal 2 times 24 plus 2 times 18. And that equals 84 inches. So now that we know this perimeter, we can set that equal to our proportion or to our ratio. So 4 over 5 is going to equal 84 inches over the perimeter of figure 1. And now, since we can have our proportion set up, we can solve for our perimeter of figure 1. So that's going to equal 84 times 5 divided by 4. That will give us our perimeter of figure 1. When you go ahead and plug that in to your calculator, you find out that the perimeter of figure 1 is going to be 105 inches. So that's how you use area and the ratio that we know how area is related of similar figures to find the perimeter of similar figures. So now we're going to move on to the next example. So now we're going to use perimeter to find the area. So we have a regular pentagon which has side length of 12 centimeters and it has an area of about 248 square centimeters. A similar regular pentagon has a perimeter of 140 centimeters. What is its area? Okay, so if it's a regular pentagon, we know then every single side is similar or congruent to each other, and a pentagon has 5 sides. So the perimeter of that regular pentagon is 12 times 5, which equals 60 centimeters. So pentagon 1 has a perimeter of 60 centimeters. We know that the similar pentagon has a perimeter of 140. So we're going to set up our ratio of A over B equals 60 over 140. And this reduces down to 3/7. Okay, so we now know the ratio A over B, but we want to figure out the area. So we need A squared over B squared. Okay, so let's just go ahead and square our ratio. So that's going to give us 3 squared over 7 squared, which is 9 over 49. So that's how our two areas of these polygons or pentagons are going to be similar to each other. So we know our first regular pentagon has an area of about 248 square centimeters. So let's go ahead and set up our ratio now. We have 9 over 49 equals 248 over the area of our similar pentagon. That's what we're going to solve for. So once we cross multiply and divide, so we would do 248 times 49 and divide that by 9. That equals x. Put that into your calculator and you'll find that the area of the second similar regular pentagon is approximately 1,350 square centimeters. So that's how you solve when we are using the perimeter to find the area. Okay, so that's it for today. I hope you enjoyed the lesson and look forward to seeing you all soon. Take care. Bye-bye.